In this video, we will be demonstrating about the microcontroller called mbed LPC 11U24. Before going into the programming, we need to know about the ARM mbed LPC 11U24. It is a ARM processor of 32-bit which is having Cortex M0 architecture. It is packaged in a dual inline package form so that it can be easily connected to breadboard or to PCB. Coming to the characteristic features, it has a 32 kilobyte of flash, 8 kilobyte RAM, and it can be interfaced using USB devices, SPI, I2C, ADC, and other input-output devices. The board is usually powered using 4.5 volts to 9.0 volt analog supply or by using a 5 volt USB. The device is featured with 2 SPI and 6 ADC channels by default. The board also includes 4 internal LEDs which are internally connected to processor and which can be used in program as LED1, LED2, LED3 and LED4. After knowing this, we'll go into the coding of these LEDs. In this video, we'll be showing how each LEDs can be blinked and the counter experiment and how a temperature sensor can be interfaced. First going to this, in this code we will be explaining, I have already said that the ARM mbed board will have 4 internal LEDs. Now we will see how all these LEDs can be glowed. This is an mbed.header file which has to be included so that all the functions can be used. This LED1, LED2, LED3, LED4 have been given the pseudonym called LED1. These are the pseudonames which are assigned to LEDs. From here the actual execution of the program starts. We are including this in the while loop. This while one means it's an infinite loop making the LEDs to glow continuously. This mbed board is an active high board. That means if we want to turn on the LED, we have to give 1 to that board. We can see we are giving to all LEDs 1. And we are using an wait function. This is to make the LED on for a certain amount of time and to make the LED off for a certain amount of time. This wait is an inbuilt function which is defined in mbed.h so that user need not to worry about defining his own delay function. And after this wait, it will a particular amount of delay will be generated, and after that we are making the LEDs to glow to 0. And once again we are giving wait, and once again we are making the LEDs to on. This goes for infinite amount of time since we have kept it in while 1. This is one type, and this all LEDs can be glowed using some other pattern also, and I will explain another code through which the LEDs can be controlled. In the previous code we saw we were giving each input to LEDs at once, but it is not mandatory to give like that. All LEDs can be using an option called bus out. All LEDs can be included in one pseudonym, and if you once give it to that pseudonym, all LEDs can be controlled using that. In this program, all the LED 1, 2 and 3 and 4 are defined by a pseudonym called LED, and they are defined in bus out, means that all LEDs can be accessed at a single chunk. We are keeping it in the while one so that all LEDs are accessed at a single time. And this we are giving for this variable 1 so that this all LEDs will be on, and this wait function, this will be internally generated function. It will create a required amount of delay, and once again we are making it to 0, and once again we are giving the delay, and this part of the loop will execute infinitely so that the process will continue forever. And we will show the video demonstration of these videos. You can see using the bus out, all LEDs are glowing at a time. In this we can see that one LEDs are glowing one after the other because we have used the digital port. Unlike in the first video we saw all LEDs are glowing at once because we used bus out, and in this code we are using digital out. So LEDs are glowing sequentially one after the other. This is the main difference between bus out and the digital out. And now next we will go for the counter operations, means how the LEDs can be used for counting. Here we are using a 3-bit counter, that is we are making the LED to count to represent from 0 to 8, 0 to 8, that 0 to 7, that is it's a mod 8 counter. Here we are making the 3 LEDs using bus out, and we are keeping it in a for loop, and we are assigning the values to the LED so that will count operations will be performed. It's a simple program. The logic will be same as the previous codes. Now we will show the video demonstration of this.
Thank you.
We can see this LEDs are going in the counter fashion. It is going from 00001 like that. Here it's a 4-bit counter. It is going from 00 to 111.
4 ones.
In the next code, we will see how we can read the analog values from the sensors connected. In this for this experiment, we have connected a temperature sensor called LM35. In this code, we can see the header file called mbed.h is included, so that all the serial communication that the baud rate around 9600 will be set for this. This serial trans take care of all the transmission and reception purpose. We will connect the analog sensor to the P20 of the mbed board, and this is the main from where the execution starts. Since we need to store the value which is read from the analog sensor, since the values will be in the decimal range, we are creating it as a float variable. And since we will be obtaining the values continuously, we will be keeping it in the while loop. This sensor read will continuously read the value from the analog sensor, and that value will be put in the variable called SEN. And to differentiate between each reading, we are generating a delay using this wait function. No need for user to write his own function. This wait will be written in the header file called mbed.h, and we are calibrating with the value called 488 into 8.125 for the correct values, and we are printing these values on the serial window, and we will show the video demonstration of this. Here we can see that a temperature sensor LM35 is connected, and you can see that the serial window which is continuously monitoring the temperature of the environment. Thank you. This is in this video.